I know not how long I have toiled at this wheel, nor how much longer my penance must be served. All that I know is I must bore out this wretched spit of metal, bore for all I am worth, come hell, high water, plague, or pestilence. I will sit here and bore.
Hi, I'm Kyle, and this is Past Kyle explaining how he's going to make a bearing carrier. Okay, I am going to make a bearing carrier for this bearing. This bearing is the inboard bearing. As you can see, it's quite a thick bearing, and the bearing carrier is just going to be like a sleeve of metal to go around it. It'll press fit in there and then be thick enough that I can weld that sleeve onto the car so I can take a bearing out if I ever need to. This is the metal I'll use for making the bearing carrier. So we need to basically make a sleeve to fit around that. So we have got a lot of turning down to do. This is the first big lathe project for Past Kyle, and as such, he's got a lot of trepidation just mounting the piece. Next part of this is to part off the bearing carriers. That means he's cutting a chunk off to work with. Is putting the piece in the lathe to cut the end off the best way to do it? No, not remotely, but he'll learn. No, not that. First, he's trying a parting blade, the correct tool for this operation. Annoyingly, this piece is stymieing his progress with the trick hiding under its skin. The angle grinder is a much better tool for this job. Obviously, he's got a little size problem, but he'll manage. Unholy father of shop safety?
Welcome, my son. How long has it been since your last injury?
I don't think that a splinter should count as an injury.
Would it have been prevented with the proper PPE? A pair of gloves, perhaps?
14 days?
What have you to confess?
Son, you're going straight to hell. Questionable decisions aside, progress was made. Enough to use the character builder. I like how you can see the different cuts here. The thickest cut that I made was with a grinder, and you can see how deep I got on all of the sides there. And then this middle section here with the circular scratches, that is the lathe and the saw, and then you can see these just straight, these angular cuts there. That was just hand sawn. We're finally frickin' through this. Now that Kyle has a hunk of metal, he can cut down the perimeter in order to reduce the diameter. On the lathe, this process is called turning. I'm having a little bit of trouble turning this piece. There's been a lot of chatter. There are like these zebra lines on it. So what's happening is as I'm turning it, I'm seeing the tool post move back and forth. There's two things that might be causing that. It might be that my insert is getting dull. Not likely. New inserts usually break rather than dull. It might not also be the right insert. Close, but the insert shape shouldn't affect the finish that dramatically. Another thing might be it might not be biting enough material. While taking deeper cuts is a solution here, shallow cuts are not the issue. But to unravel this riddle, we need to go on a tangent to talk about how to change the properties of steel. Steel is an awesome material. Besides having great all-around physical characteristics, a fascinating attribute of steel is how its properties change with heat treating. Heat treating is a complex science in which I have very little experience, but I can tell you about the basics of a process called hardening. Steel can be hardened by heating to red hot and then cooling quickly, usually in water or oil, or sacred blood if you wish to lock in the spirits. Hardening makes the material extremely resistant to abrasions, but it also makes it brittle, increasing its likelihood of shattering. Editor's note: while hardened metals can shatter, more common failure modes are cracking, snapping, or chipping.
In my demonstration, I was hoping the hardened metal would fail in a more spectacular manner under the hammer blows, but it only cracked and ripped. You can still see the difference in how the hardened metal broke under the hammer blows while the untreated metal merely deformed. If you want to see a more spectacular failure, check out the hydraulic press channel crushing ball bearings. I'll put a link in the description. And now back to Kyle.
Some examples of hardened steel are cheap padlock shanks, ball bearings, and screwdriver tips. The shattering problem is usually mitigated by tempering, or in some instances, case hardening.
With case hardening, similar to an M&M, only the outside shell is hardened. This allows the surface of the material to be resistant to abrasions while allowing the core to soak up impacts without fracturing. Great properties for parts that will see a lot of wear and need to be able to withstand violent impacts. Some examples include firing pins, landing gear axles, engine camshafts, and large hunks of steel in scrapyards.
This is why I had so much trouble. The metal had a near impervious and very frustrating hardened outer shell. Once I cut deep enough to get through that shell, past Kyle, was able to make progress in the nice, soft core metal. Tradition dictates that we face the part as the first operation, but past Kyle doesn't recognize that tradition yet. To start the center bore, Kyle is using drill bits. A fun thing about drilling on the lathe is that the bit stays static while the part turns. This part's turning too slow, but whatever. Next, he's drilling up to his largest bit size, a 1/2 inch, and then he'll start boring. This part continues to be a learning process. For instance, Kyle is learning that cutting the face, as opposed to boring the interior, is a poor choice.
All right, got an update for y'all. Now I've got a 1/2 inch hole in the middle of this piece, and now I'm trying to bore out that with the inserts that I have on hand, just facing down in the middle as I go. Turns out they make boring inserts for a reason. So I am ordering some actual boring inserts, and those will be here about now. Not actually now, because it takes 2 weeks, but through the magic of editing, now.
A boring tool is specifically shaped to fit into a round hole, as opposed to a standard turning tool, which is usually rectangular and doesn't fit at all.
2 weeks later.
Past Kyle got tired of boring, don't we all, and decided to finish the exterior to break up the monotony.
We have my original finished surface up here, pretty rough, and then we have the one that I just tried here. This is with the 1/2 inch insert holder, also rough, and then we have this final one here, which is same 1/2 inch insert holder, same angle that you can see down there, but we have the tailstock propping it up there.
So many. No one has bored as much as me.
Okay, that's enough. When machining critical measurements, operators like to creep up on the dimension by cutting off smaller and smaller amounts to ensure they don't remove too much. You can always cut more. You can't put it back.
Test fit time. I have tried to cut this to a interference fit, which means that this bearing here shouldn't fit into this hole without a pressing machine. A press. So I'm gonna see how that fits. Okay. Well, that's not supposed to do that. Happens to be like a really close sliding fit.
that's not a press fit. So, the what went wrong? Okay, pause. Because past Kyle is handling this incredibly nonchalantly. A more appropriate reaction would be, what the ever-living f***? How the hell can that be wrong? Have I wasted 5 months on this part? The point of a bearing carrier is to hold the bearing securely. If the bearing can slide in, it can slide out. This part is wrong. But how did that happen?
I think I have an idea about what happened, so...
Editor Kyle here again. Past Kyle did figure out what went wrong, but in the emotion of the moment, he didn't explain it that well. Which leaves me to try again. So, calipers like these should show 0 when they are closed. However, due to dirt or a low battery, they can lose a few ticks. When that happens, they will not show 0 when they are closed. And more importantly, any measurements they make will be off by that amount shown when they were closed. By the way, according to the internet, this is called 0 point or 0 offset error. So be sure to titillate your friends with that tidbit of trivia at your next tete-a-tete. Here's an exaggerated example. Say these calipers are showing negative 0.5 inches when closed. When I measure this 1 inch distance, they will show 0.5 inches. And if I want to make a hole that's 1 inch wide, using these calipers would lead me to make a hole that's actually 1.5 inches wide. And on a much smaller scale, the same thing happened to me. The calipers lost a few ticks and showed negative 0.0015 inches when closed. This led me to bore a hole that was 2.1655 inches in diameter instead of 2.164.
And now I always double check the 0 on my calipers.
So the issue is the internal diameter of this, I overbored. It's too big. I have to find a different way of keeping it in there. My plan right now is to put snap rings on either end. So I'm gonna have to cut some snap ring grooves. I'll also have to extend the size of the bearing carrier so I have some material to retain that snap ring in. So these bearing carriers are gonna have to get bigger.
While Kyle waits for the grooving tool to arrive, he's facing the end and cutting chamfers. Because, as a parasocial friend puts it, chamfers are what separate us from the animals. For grooving, Kyle has set the cross slide to be parallel with the axis of rotation. That's because there are 2 tricky parts about making snap ring grooves. First, the insert is long and thin, so it breaks easily, like a freaky fingernail or a spaghetti noodle. Second, the snap ring needs to be placed snugly on either side of the bearing, so Kyle is using the indicator on the cross slide to precisely track the grooving tool. That was a hard one. The final step for these parts growing up and becoming a real boy is parting them off. A terrifying, chattery process. Kyle's using an extra thick parting blade for some reason, but you do you. The reason parting is much harder than single point turning is because... Yahtzee. Because we lengthened the bearing carriers, the other end of the material had to be turned down and bored to size. But that's more of the same, so we'll skip that. Does the bearing still fit? Some tasks require a set of specific, well-made tools. Snap ring pliers are such a tool. 10 tries, first try. Need I say more? And here's the finished products. Not exactly how I designed them, but still beautiful and, more importantly, functional. That's a wrap.